number 10 of the worksheet Forces on Inclined Plane. A particle P is released from rest at the point on a smooth plane inclined at 30 degrees. So smooth plane means that there is no friction. Inclined at 30 degrees, so we have a plane, an inclined plane with angle 30 degree. Particle P is released from rest at a point on a smooth inclined plane. So there's the here's the particle P. It's U is equals to 0 for the particle. Find the speed of P when it has traveled 0.9 meters. So that means for part 1, S is also given, which is 0.9 meters. And we have to find this V. Okay, so we have U, we have S, we need to find V, but that's not enough information. We need one more perimeter to apply equations of motion, and that could be A, the acceleration, or T, the time. Now we can find the acceleration using Newton's law, which is forward force minus backward force equals ma. F forward minus F backwards equals ma. Let's apply that. There's no forward force. No, in fact, it is going downwards. So it's going to be, the forward force is going to be mg sine theta, the component of the weight down the slope. Okay, there's no backward force though, because the friction is 0. And another component of the weight is mg cos theta. And opposite to that, there's the normal contact force, which is represented by R. Okay. So forward force is going to be mg sine theta minus backward force is 0 equals to mass times acceleration. Mass is not given to us, we can just cancel it. G is 10, sine 30 equals A, which gives us A equals 5 meters per second square. Part 2. Find the speed 0.6 seconds after it is released. So for part 2, U is still 0 because the object starts at rest. Time is 0.8 and we have to find V. Okay, so again, acha, we were supposed to find V in the first part. So we're not done with first part yet, sorry. A aa gaya, so that's not our final answer. We have to find V. So U is 0. S is 0.9. V is question mark. A is 5. So which equation of motion should we use here to find V? Something that gives us V from U, S, and A.
V square is equals to U square plus 2AS.
Right. So it's going to be V equals square root 0 square plus 2 times 5 times 0.9, which gives us V equals 3 meters per second. That's the complete solution of part 1. Now for part 2, you're given U equals 0, T equals 0.8, and V is what we have to find. Again, that's not enough information. We need a third value, that of A or that of S. A can be found using forward minus backward force equals ma, which we've already done for part 1. So acceleration is going to be the same. It's the same particle. So of course the forward force minus backward force equals ma is going to stay the same. So acceleration comes out to be 5. Now which equation of motion should be used to get v from u, t, and a?
Plus V equals U plus A2.
Right, v is equals to u plus 80. So 0 plus 5 times 0.8, which is 4 meters per second. That's question 10. Okay, I'm going to copy question 11 now. Any questions so far from question number 10?
No, ma'am.
Let's take a look at question number 11 now. Particle of mass 0.5 kg starts from rest and slides down a line of greatest slope of a smooth plane. So starts from rest. So again, u is equals to 0. Smooth plane means friction is equals to 0. Okay. Plane is inclined at an angle 30 degree to the horizontal. Particle with mass 0.5 kgs. Okay, find the time taken for the particle to reach a speed of 2.5. Okay, so for part 1, u is 0 as given in the question, v is 2.5, t is what you have to find. But again, that's not enough information for us to apply equations of motion. Either we should know A or we should know S. We need at least 3 values to find the other value. So we cannot find S from the information given, but we can find A using Newton's law, forward force minus backward force equals ma. Okay. The particle is going downwards. Okay. So in this direction, we have the component of the weight, which is always mg, the sine component, sine theta. In this direction, we always have the other component of weight, which is mg, cos theta. In this direction, we always have the normal contact force R. And do we have any backward force? No, because the friction is 0, so there's no force in this direction. Okay, so now we need to find A. So this is going to be forward force, mg sine theta, minus backward force 0 equals ma. M and M can be cancelled. 10 sine 30 equals A. So A here is also 5, like the previous question. 5 meters per second square is A. So now U is 0, V is 2.5, A is 5, so T is question mark. So you have to use one of the equations of motion, which is going to be V equals U plus AT like last time. So 2.5 equals 0 plus 5 T, T equals half seconds. That is part 1. Any questions so far? इन सारे क्वेश्चंस में मोस्टली यही होता है कि इक्वेशन ऑफ मोशन लगानी होती है, बट एक पैरामीटर मिसिंग होता है, विच इज द एक्सेलरेशन. उसको फाइंड करते हैं यूजिंग फॉरवर्ड फोर्स माइनस बैकवर्ड फोर्स इज इक्वल्स टू ma, and to get to that you have to resolve the component of the weight. Next part is when the particle has traveled 3 meters down the slope. So now we know S. Part 2, S is 3 meters. Okay. When the particle has traveled 3 meters down the slope from its starting point, it reaches a rough horizontal ground. Okay, so that's S might not be 3 meters. Let's see what the question is saying. Okay, so here's the slope. And it's saying when the particle has traveled 3 meters down the slope, so this slope is 3 meters long. So it started from here where U is 0, and then it comes down to the bottom of the slope, and it says it reaches a rough horizontal ground. If it's rough, that means now you will have friction. The slope was smooth, so there was no friction, but the horizontal ground, it's mentioned that it's rough. So now you're going to have some friction here. So if the particle reaches here, it's going to be moving in this direction. So there has to be some friction in the opposite direction. So when the particle has traveled 3 meters down the slope from its starting point, it reaches a rough ground at the bottom of the slope. The frictional force acting on the particle is 1 Newton. Okay, so friction is equals to 1 Newton. Find the distance that the particle travels along the ground before it comes to rest. Okay, so let's say somewhere over here it comes to rest. So V is going to be equals to 0. Okay. Now we just have one perimeter in this horizontal surface. We only know V is 0. We need at least 2 more perimeters to apply equation of motion so that we can find the distance that the particle travels along the ground before it comes to rest. So we know that V is 0 and we have to find S. We don't have anything else. Let's find acceleration first. Acceleration is can be found using Newton's second law of forward force minus backward force equals to ma. So there's no forward force mentioned, it's 0. And now since the object is horizontal, you don't even have mg sine theta, mg cos theta anymore. That's only for an inclined object. For a horizontal object, this is mg, the weight. It doesn't have to be resolved into any more components. And this is r. Okay, so let's write that as well. This downward force is, what was the weight? 0.5 kg, so it's going to be 5 newtons. mg. So 0.5 into 10 is 5. And in the upward direction, we're going to have the normal contact force R. Okay. So to find acceleration, it's going to be forward force, 0 minus backward force, 1 equals mass times acceleration. So 0 minus 1 equals, what was the mass? 0.5 equals A. So A comes out to be minus 1 upon 0.5, which is minus 2 meters per second square. So now we know that V is 0 and we know that A on the horizontal rough path is minus 2. And we need to find S. Still we're 1 perimeter short. We either need the time it takes to move on the horizontal path from here to here, or we need the U, the speed at this starting point. Now we can find the speed by finding v of this part, because v of the slope, that is the final speed at the bottom of the slope, is going to become u for the horizontal motion. So let's use the downward motion again. Here the particle had a speed of 0 because it started from rest. We had also find the acceleration earlier. This was at 5. So A is 5 down the slope. And what else do we have? Distance is 3 meters. This distance S is 3 meters. Okay. So use these 3 parameters to find V at the bottom of the slope, which will serve as U for the horizontal motion. Okay. So V can be found from we have S, we have U, we have A, we have V. So we can use V square equals U square plus 2AS. Square root 0 square plus 2, 5, 3. Under root 30. Okay, you may use the decimal value or you may just use the surd form, that is the square root form, it's fine. Okay, so we know that now for the horizontal part of the journey, this is U. So rewrite this. V is 0 for the horizontal part of the journey because it's asking us to find the distance when the object comes to rest. So it comes to rest here. So V is going to be 0. This is V. And now U is the same V for the bottom of the slope, which just came out to be under root 30. And that A for this region we had calculated, that was -2. Use these 3 to find S. So V square equals U square plus 2AS. 0 square equals under root 30 square plus 2 minus 2S, which comes out to be, after rearranging and all, you should get 7.5 meters. If you have any questions from question 11, please ask.
No, miss.
Okay, now I'm going to copy question 12. Particle P and Q move on a line of greatest slope of a smooth inclined plane. P is released from rest at point O on the line and 2 seconds later passes through the point A with speed 3.5 meters per second. So let me draw this. There's a smooth inclined plane, meaning friction is 0. P is released from rest. So that's P, let's say. It's released from rest. That means its U is equals to 0. At a point O on the line, so this is point O, and 2 seconds later passes the point A with the speed of 3.5. So here there's a point A where its speed becomes 3.5 and the time is 2 seconds. Time from here to here is 2 seconds. Okay. Find the acceleration of the particle p. So we have enough information to find the acceleration. Let's do that. U is 0. V is 3.5. T is 2 seconds. Which equation of motion are we using here to find A?
V is equals to U plus AT.
Yes. V is equals to U plus AT. 3.5 equals 0 plus A times 2. A comes out to be 1.75 meters per second square. Okay. We found the acceleration. Next, it's asking for and the angle of inclination of the plane. So you have to find this theta now. Theta equals to question mark. So we don't have rise over run or opposite and hypotenuse or base for us to be able to find theta. So instead, what we'll do, we already know the acceleration. So we're going to use Newton's law again. Forward force minus backward force equals ma. Okay. On P, since it's going downwards, there is going to be a forward force, which is going to be mg sine theta. Since there's no friction, there's no backward force, but we have a component of weight in this direction, which is the cos component. And opposite to that, we have the normal contact force, which is R. So forward is mg sine theta, mg sine theta minus backward is 0 equals ma. Okay, so m and m gets cancelled. 10 sine theta is equals to acceleration, which is 1.75. Sine theta equals 0.175. Theta equals sine inverse 0.175. What do we get? 10.07865. So rounded to 10.1 in one decimal place. Angles in degrees get rounded to 1 decimal place. So this is 10 point, it's better to use the longer answer, 0786. Okay. So we have found acceleration of P and we have found the theta of the inclined plane. From the equations of motion and from forward force minus backward force equals to ma. Okay. Next part is, at the instant that P passes through A, particle Q is released from rest at O. At time t seconds after Q is released from O, the particle P and Q are 4 point, what is that? 4.2 meters, 4.9 meters apart. Find the value of T. Okay, let me draw this so that it makes more sense. Same slope. So theta is 10.07865. Particle P is released At the instant that the particle P passes through A, okay, this was P, and then it passes through A, and that happened in 2 seconds. So now P is here after 2 seconds. Okay, so this time is 2 seconds. At the instant that P passes through A, particle Q is released from rest at O. So now this is a particle Q that is released. Let me draw the particle Q, let's say behind it. So it's right there in place of P, but since there is its space, I'm drawing it above it. But actually it's where P was earlier. Okay, so particle Q is released. Let me read that again. At the instant that P passes through A, particle Q is released from rest at O. At the time t seconds after Q is released from O, the particle P and Q are 4.9 meter apart. Okay, so at the time t seconds after Q is released. Okay, so time for particle Q is t. So then time for particle P is going to be, P was released 2 seconds earlier before Q was released. So time for P will be T plus 2. Since the question says that at T seconds after Q is released, that means the time that you're going to use for Q is going to be T. So then the time you're going to use for P is going to be T plus 2, because P was released 2 seconds before Q was released. Okay. And it says that the distance of the particle P and Q are 4.9 meters apart. Find the value of T. So that means, let me draw that again. Here's P. It covers this much distance in the given time. This is the distance it covers in T plus 2 seconds. And Q starts at the same point. Let's say Q covers this much distance. So this is going to be distance covered by Q, and the time we used for Q is going to be T, and this is going to be the distance covered by P, which I'm supposed to write P here, and the time we'll use for that is going to be T plus 2. And the distance apart is 4.9 meters. So this is 4.9. So that means the equation we're going to use is that the distance covered by P minus the distance covered by Q is going to be 4.9 meters. Now we're going to use the equation S is equals to UT plus half AT square for both of them. So for SP is going to be U. Instead of T, you're going to use T plus 2 plus half A T, which is T plus 2 squared. Now for both particles, U is 0. So this becomes 0. So SP is half times, we already have the acceleration as well, 1.75. 1.75 is going to be the acceleration for both the cases. So 1.75 in place of A. Half A T plus 2 squared, that's the distance covered by P. Distance covered by Q is going to be same U. T is now just T plus half A T squared. So that's 0. So SQ is going to be half 1.75 T squared. Okay. Now we're going to subtract these expressions and equate the answer to 4.9. So again, SP minus SQ equals 4.9. SP is half 1.75 times t plus 2 squared minus half 1.75 t squared equals 4.9. So 1.75 divided by 2 is 0.875. Expand the brackets, a square plus 2ab plus b square minus, that's 0.875 t square equals 4.9. Expand the brackets, 0.875 t square plus times 4 is 3.5 t plus 3.5 minus 0.875 t square equals 4.9. These get cancelled. We have 3.5 equals 1.3. This is t here, and 4.9 minus 3.5 is 1.4, sorry. And then t is equals to 1.4 over 3.5, which is 0.4. 0.4 seconds is the correct answer. So we had to use equations of motion to get the expression for distance covered by P and distance covered by Q, because we're given that the difference of their distance is 4.9. But for Q, the time was the regular time T, but for P, the time was 2 seconds ahead of Q's time. So for SP's expression, you had to use T plus 2 for the time and not just regular T. Okay. I think that's enough practice from this topic. Tomorrow onwards, we're going to start